Hello, my students. Your physics teacher Hassan Darwish with you. I'm going to explain chapter 10, part 1, which is about capacitors. Now, in this part, we have two objectives. Objective 1, define a capacitor and explain its capacitance. In the second objective, study the charging and discharging of a capacitor. Okay? In this video, I'm going to cover objective 1. Let's start. Now, every device here is a capacitor. You see, they have different shapes. This is also a capacitor. This is a capacitor. This is a capacitor. In reality, what is a capacitor? We studied capacitor in second secondary last year, if you remember. In reality, what is a capacitor and what is the structure of a capacitor? Okay? In fact, this is a capacitor, as you studied last year. The capacitor consists of two conducting surfaces, surface 1 and surface 2. Okay? And there is a space between the two surfaces. This space between the two surfaces here could be air or vacuum and could be filled with an insulator. We call it dielectric material. In reality, this structure is called capacitor. Okay? So a capacitor is a structure or a device that consists of two parallel conducting surfaces facing each other. Okay? So every component here consists of two conducting surfaces. Here, for example, we place two, say, aluminum foils separated by dielectric material and then rolled like a sandwich. Clear? Here we have two parallel conducting surfaces, parallel plate capacitor. Look here at the surfaces. Surface 1, surface 2, surface 3, surface. Every two surfaces here, parallel surfaces, make a capacitor. That's why this device here or here is a capacitor of variable capacitance, usually used in tuning. Okay? So capacitor and capacitance. Capacitor. A capacitor is an electronic component, an electric device which stores what? Electric energy or electric charge. That's the main role of the capacitor, to store energy. Clear? We have here two surfaces, as I said. This is surface 1, call it A, and this is surface 2. Okay? Now, if we connect surface A to the positive pole of a DC generator or of a battery, then it collects positive charge. And if you connect the second surface, say B, to the negative pole of a battery or any DC generator, it collects negative charge. Clear? Hence the definition: a capacitor is an electric device which stores electric charge, positive charge, negative charge. But as you know, as a result of positive charge and of negative charge, there will be created electric field in between the two surfaces, as you see here. Electric field, as we studied last year. Electric field similar to gravitational field, okay, or magnetic field. Now this electric field is directed, as you see it is a vector, directed from the positive charge to the negative charge. Very good. So due to the existence of this electric field, as you see, the capacitor stores what? Electric energy. Hence, what does the capacitor do? It stores electric energy. Okay, that's the main purpose of the capacitor. So a capacitor is a device which stores electric energy or electric charge, as you see. What is the structure of this device or this component or this element? The structure is simple. Just consists of two conducting surfaces separated from each other by vacuum or air or dielectric material, which is called the insulator. Okay? Good. Now, what is the symbol of this capacitor? Here is a symbol. Okay? Let me displace this. Sorry. That's a symbol. Okay? This is surface 1, as I said. Sorry. This is surface 1 or surface A. Here. This is surface 2 or surface B. Clear? Now, if you connect here the capacitor to the terminals of a battery or any DC generator, what happens? Here you will collect positive charge, and here you will collect what? Negative charge. Okay? So it is formed of two conducting surfaces separated by air or vacuum or insulating material, which is called dielectric. That's the main definition of a capacitor and the main purpose. Okay? Now let's see in the next section how the charge collected on the capacitor depends on the applied voltage. Okay? Say you applied on this capacitor a voltage 3 volt. What is the amount of charge collected? And suppose you increase the voltage to 6 or 10 or 12 volt. What happened to the charge? Does it increase or decrease? Let's see. In reality, experiments showed that the charge Q collected on a surface, I mean one surface of the capacitor, is proportional to the voltage, proportional to the potential difference, means voltage. This is the potential difference. UAB equal VA minus VB. You studied in back 1 and in first secondary in reality, between the two conductors. Okay? So Q proportional to U. What does it mean in mathematics? Y proportional to X. What does proportional mean? Yes, proportional means the ratio is always constant. Means Q over U is always constant. That's a mathematical expression. Means the graph is a straight line passing through the origin. Okay? Okay. So Q over U equal constant. This constant is called what? C. So this will imply Q equal CU. And be careful here about the sign. If I use here the charge on the surface A, which is QA, I say UAB. If I use the charge which is negative on surface B, I say CUBA. Okay? So that's the relation. As the voltage increases, the charge increases. Okay? Here is the graph. This is the voltage U, and this is what? Q. So Q proportional to U means the graph is what? straight line passing through the origin. Okay? Now what is C, which is constant? C is called the capacitance of the capacitor. It means how much amount of charge can the capacitor, for example, store or withstand, which depends on what? Geometry of conductors. What does this mean, geometry of conductor? Means here, the capacitance C for this capacitor, let me change the color, sorry. The capacitance C of this capacitor is different from this C. Also different from this C. Okay? Why? Because, sorry. Because the structure or the shape of this is not the same as the shape of this, not the same as the shape of this capacitor. So each capacitance has different value. And let's look here. This C is 4,700 microfarad. You can read another number here. Okay, not the same number. Also here, different number. So each capacitor has different C. Okay? C is called capacitance of the capacitor, and the SI unit of C is farad. Farad in honor to Michael Faraday, who invented the first capacitor. Okay? So 1 farad, as you see, is equal to 1 coulomb over 1 volt. Farad equal coulomb over volt. Okay? Now, let me also remind you with the electric energy stored in a capacitor when it has a charge Q is W equal half Cu squared. Also, you can write it half Q squared over C. For example, you remember this rule. Q equal Cu. Okay? Then what does this mean? U equal Q over C. Now replace U here, replace it here, you get, replace I mean U here, equal Q of, and then you get, okay, you get W equal half Q squared over C. Also you can say equal half Q U. Okay, half Q U. The same. Any problem? Okay. Now in the next video, I will start explaining the charging and discharging a capacitor. Okay, we see how we explain them. Okay, that's enough for today. Take care. Bye bye.